In this lesson, we're going to be looking at angles that are formed by parallel lines and a transversal. We'll start with parallel lines, and if you look up here, we have line AB and CD, and it says that those lines are parallel. And again, parallel means that it's two lines that are never going to intersect. So these lines would never intersect each other, meaning they would never cross or run into each other. Now a transversal is shown in the diagram below it. A transversal is line PQ. When you have a line that goes through a set of parallel lines, that is called a transversal. And what is created here, you can see that there are 8 angles that one transversal creates when it goes through 2 parallel lines. So this transversal going through these 2 parallel lines created 8 different angles, and we're going to break down the angles that are created by a transversal today. The first 2 types of angles we'll look at are exterior angles. The exterior angles are the angles that are outside of the parallel lines. So these are your exterior angles. Then you have interior angles. The interior angles would be the angles that are positioned in between the parallel lines. The first type of interior angles that we're going to look at are alternate interior angles. So we're going to break this down. And when we talk about alternate, we're meaning opposite sides. So if you look at angles 4 and 6 highlighted in blue, those are alternate interior because they're on the opposite sides of the transversal and they are between the parallel lines. These angles, alternate interior angles, they are congruent, so they are equal to each other. They have the same measure. Same with 3 and 5. 3 and 5 are in between the parallel lines, and they are on opposite sides of the transversal, so they are alternate interior angles. So they also have the same measure. The next pairs of angles that are created are alternate exterior angles. These are alternate, which means they are on opposite sides of the transversal, and they are exterior, which means they are outside of the parallel lines. So we have 1 and 7 are outside of the parallel lines, and they are on opposite sides of the transversal, so those are alternate exterior. And the other pair is also 2 and 8. They are outside of the parallel lines and on opposite sides of the transversal, so they are also alternate exterior angles. Alternate exterior angles, just like alternate interior angles, they have the same measures as well. We also have corresponding angles. And when we have a transversal going through 2 parallel lines, we created 4 pairs of corresponding angles. And corresponding angles are going to be on the same side of the transversal, and they are congruent angles. So if you look up here, angle 1 and angle 5, they are corresponding angles. They have the same exact measure, and they're on the same side. Same with 4 and 8. On the right side of the transversal, we have 2 and 6. And then 3 and 7 would be a pair of corresponding angles. So we had 4 pairs of corresponding angles. Angle 1 and 5 was a pair. Angle 4 and 8. Angle 2 and 6. And then angle 3 and 7. Now we're going to look at finding the measure of angles when we're given a transversal that goes through 2 parallel lines. And if we're given any one measure, we could figure out the measure of every other angle that we have. So I'm going to take angle 2, and let's just say angle 2, the measure of angle 2 is, let's say, 60 degrees. So if the measure of angle 2 is 60 degrees, which is right here, well, that means that its alternate exterior angle, angle 8, is also 60 degrees. We also know that its corresponding angle, angle 6, is also 60 degrees. 6 has the alternate interior angle of 4, so that means that angle 4 is also 60 degrees. So we just had 4 angles there that were 60 degrees. Now to figure out what the other angles are, because 1 and 2 are on this straight line here, if 2 is 60, a straight line has a measure of 180 degrees. So if angle 2 was 60, angle 1 then has to be 120. I could look at 1 and 3, and 1 and 3, they're created by a pair of intersecting lines. These would be vertical angles too. I could look at them that way. And because they're vertical, they are the same. So 1 and 3 are both 120 degrees. 3's alternate interior angle is 5. So that means angle 5 is 120 degrees. And then 3's corresponding angle is 7. So that means that 7 is also 120 degrees.